Hey everyone, welcome to the second part of our little introductory kind of pre-trigonometry videos where we're talking about getting a deeper understanding of these trig ratios and how they work. Now, in the last video, we talked at length about how the different sides of right angled triangles interact and how that's dictated by the angles for the particular triangles involved. Hopefully after that video you've had some kind of intuition as to how this thing works. Now today we're going to be looking at applying one significant bit of information to these trig ratios and then looking at how that allows us to do these questions in the first place. Now hopefully this will be a short video, but in this video, we are looking at how trigonometry works for similar triangles. We've looked at similar triangles in the past. We described those as triangles that are the same in terms of they're proportionate to one another, they're proportional, except one is either enlarged or shrunk. So I'm drawing two triangles. They're roughly the same, at least with how I'm drawing them proportionally, but they're just a different size. Now we say that these are the same size when the angles are the same. So this angle, and obviously because these are right angled triangles, they're going to be the same. And when their sides are proportional. So for example, with something like this, if I had, for example, 4, 6, 12, and my larger one had the measurements of 8, 12, 24, we can see that to get from each value here to the numbers on the left here, each of these values have been scaled up by 2. So to get from this triangle, from right to left, we multiplied everything by 2. That's what we mean by in proportion. Now, I'm going to rub all of this information off, and we want to investigate something in terms of these ratios. Now, I'm going to pick a relatively nice looking ratio, the nicest I can find here. A lot of these decimal points, we have a lot of these crazy digits, and they're going to be irrational numbers. I'm going to pick one particular ratio that gives me a rational thing. So this is cos of 60 here. So something that we can see based on this table is that, and once again, if you didn't watch the previous video, I'm using a really old school trig table, what we used before calculators got popularized in schools. So a lot of us doing this now or in the past 10 to 20 years probably didn't need to look at this, but I'm using this just because I think it gives you a really good intuition as to how this stuff actually works. So one thing that is written here is that cos of 60 degrees equals to 0.5. Now, another way of writing that is cos of 60 equals to 0.5 is just 1/2. So what that essentially tells us is that if we draw this a little closer now, if I had an angle of 60 degrees, now remember cos relates the adjacent side to the angle and the hypotenuse. So on this smaller triangle on the right, so this is saying cos 60 is equal to an adjacent side of 1 over a hypotenuse side of 2. So let's write that in. This is a recap of what we did last year. But this is just to give us a deeper understanding of how these work here. But now, what's important to note here is that this thing here, it's just a fraction or a ratio. So that means I can have any value of an adjacent or a hypotenuse as long as when I set up this fraction, it gives me a half or 0.5. So if I had the same angle, So for a similar triangle, I would also get the same thing if I had, for example, 2 and 4. Because if I put into my calculator cos 60, that gives me 0.5. But cos 60 is the same as opposite as a ratio of the, adjacent over the hypotenuse. So this is the same as 2 over 4, which is the same as 1 over 2. So no matter what sizes of angles we're doing here, these are always going to work for the actual trig ratios. Now, that's to say that now we're not just limited to one particular triangle. We can do this for any triangle. And the ratios here, cos 60 for example, or I don't know, sine 45 here, they're always going to work no matter what size, because those angles lead to some kind of interaction between the opposite, adjacent, and hypotenuse. So if we have something like this, now it's going to work for all of them. I just picked cos 60 because it gives me a nice thing over here. But we can apply trigonometry to any triangle because they're all just ratios. They're all other triangles which are proportionate in some way. So this will work for these ones here. Cos 60 I'm looking at again. That will work for example, 4 and 8. And some other side. It will work for, if I do this even bigger, it will work for another similar triangle. Let's say 5 and 10. Because the ratios are always proportionate. They will always work. So this is why when we go into solving some problems, so when we have, for example, something like, let's go x and 10, and we have an angle of 40, for example, this is why we can set up the ratios. Because here we have, let's look at the sides. We have an opposite side and a hypotenuse. Cos 40 is always going to be a particular value. Cos 40 is always going to be, if we look at our, sine of 40. So here we have an opposite and a hypotenuse. We have an angle. So sine of 40, which is, let's locate that here. Sine of 40. That gives us this value here, 0.6428. So any particular ratio that we do, x on 10, or anything else, so long as this is sine 40, this is always going to equal this thing here, 0.6428. So 0.6428, I think it was, and sine of 40. So we don't really get an appreciation for this, because when we do this in school, and if you look at it in your textbooks, you just do SOHCAHTOA, substitute it straight in. But the reason it works is because this ratio, 0.6248, is going to be equal to any time we have an opposite over a hypotenuse. And this idea is what we're going to be using moving forward when we work through finding unknown sides and unknown angles. But this was just a quick little side note on trigonometric ratios and how these work for similar triangles. And this idea allows us to, it opens the door for us, because we're looking at ratios. I can have ratios between any two sides, or fractions with any two sides, like I have here. I can change the numbers, I can change the values, but it's always going to be equal to whatever sine of 40 is. And we're going to explore this a lot more in the next few videos. But that brings us to the end of the video today. Thank you for joining me, and I'll see you next time.